Hi guys, welcome to this course on NEET 2017, and we are about to witness yet again a great session. So we will discuss some physics question that appeared in NEET 2017 paper. We will discuss today 5 questions from question 6 to question 10, and I am Vikas Joshi. So now let's quickly start the day. So the first question for the day: a spring of force constant K is cut into length of ratio 1 is to 2 is to 3. They are connected in series and the new force constant is K dash. Then they are connected in parallel and the force constant is K double dash. Then the examiner is asking the ratio of K dash is to K double dash when it is connected in series is to when it is connected in parallel. We need to find the ratio of the spring constant. Okay, so the first thing that should hit your mind, seeing the ratio of the length given, is that K spring constant is inversely proportional to the length of the spring. Now, so using this technique we will solve this problem. Now let's see the solution. Okay, so as I discussed earlier, that spring constant is inversely proportional to the length, and the ratio of the length is given, that is 1 is to 2 is to 3. So we will next find the ratio of the spring constant, that is K1 is to K2 is to K3. So that is 1 is to 1 by 2 is to 1 by 3. Now let us suppose that it is equal to some constant x. So K1 becomes x, K2 becomes 2x, K3 becomes 3x. Now when they are connected in series, we have the formula like 1 upon K1 plus 1 upon K2 plus 1 upon K3 is equal to 1 upon K, where K is the equivalent net constant, which is in fact in the question that is given as K dash. So K dash equal to K, that is what we have got. Now put the value of K1, K2, K3 in this equation and get the value for x, and put the value of x here. Okay, so you will get K1 is equal to 6K, K2 is equal to 3K, K3 is equal to 2K. This will come upon substituting the value of K1, K2 and K3 in this equation and solving it, and again substituting the value of x in this. So we'll get these three values. Now when they are connected in parallel, this is the formula for parallel. The spring constant, the equivalent spring constant, that is K double dash, that becomes equal to K1 plus K2 plus K3. We are having the value of K1, K2 plus K3, 6 plus 3 plus 2, that is 11K. Okay, so we are having K double dash as 11K, and now we are in a position to answer the question. All that the examiner asked us was K dash is to K double dash, that is K upon 11K. K and K will get cancelled out, so we'll have 11K as the answer, which is second option. Okay, now let us move on to the next question. Very easy question, very basic question. The ratio of the resolving power of an optical microscope for two wavelength lambda 1 is equal to 4000 Armstrong and lambda 2 is equal to 6000 Armstrong. So two wavelengths are given and it is asking the ratio of the resolving power. It should directly hit our mind. What should hit our mind? What should hit our mind? That resolving power is inversely proportional to the wavelength. What it is inversely proportional to the wavelength. This is the basic formula that should hit your mind. So using this we can conclude that resolving power 1 upon resolving power 2 is equal to lambda 2 upon lambda 1. Here it is 1 and 2, here it is 2 and 1, since they are inversely proportional. We are having the value of lambda 2, we are having the value of lambda 1. Put the value, get the answer, that is 6000 upon 4000 we will get as 3 by 2, that is the second option. Very easy question. It hardly takes 10 seconds to solve this question if your concepts are clear. NEET is all about getting your basics clear, getting your formulas clear. You must know the formula and little bit of application, not that much, just a little bit of application, and rest is up to all your basic formulas and the study that you have put on. Okay, now next question is, okay, so it is from sound and wave chapter. Two nearest harmonic of a tube closed at one end and open at the other end are 220 hertz and 260 hertz. What is the fundamental frequency of the system? So it is talking about a closed organ pipe which is closed at one end. Okay, so it is closed at one end. So it is asking the fundamental frequency. So we should know that the difference, the key point while solving this problem is that we should know that the difference between the two nearest harmonic in a closed organ pipe where it is closed from one side is equivalent to twice of the fundamental frequency. From that logic we can directly solve this problem. Now let us look at the solution, how it is solved. Okay, so it is the stationary wave in the organ pipe. So as I said earlier, that the difference between the two nearest frequency, that is 260 hertz given 220 hertz given, 260 minus 220 is equal to 40 hertz. Okay, so the distance, the difference between the two nearest frequency 40 hertz, since it is a closed organ pipe, that will be equivalent to twice of the fundamental frequency. So 40 is equal to 2f. So from here we'll get the fundamental frequency as 20 hertz. So very simple problem. So here the option becomes first. Okay, now the next question is from which unit? Unit dimension and analysis. Okay, so what says the question? A physical quantity of the dimensions of length. What dimension? Length. That can be formed out of c g e square upon 4 pi epsilon naught, where c is the velocity of light, g is the universal constant of gravitation, e is the charge, as you all know. So it is basically asking that if we rearrange these three terms into some kind of formula, then which of these four options, which of these four formulas can depict the dimension same as that of length? So there are two methods to solve this problem. Either we can directly put on the units option by option. We have to do this problem by option. That will be an easy part. So either we can the approach that we can take is pick up the option and put the units, or we can use the dimension analysis also. But here again we have to remember that we are in a stress situation. We are appearing for the exam. I am now in an examination hall and I have to attempt 180 questions in 180 minutes. So I have to maintain my speed as well as accuracy, and I have to maintain my cool. I can't waste extra seconds. Even seconds are very important in such kind of exam. I can't dare to waste extra seconds on such questions. So directly I will go option by option. It will hardly take 1 minute to analyze all options. So first we will take one option, first option, and rather than doing by dimension analysis, we will directly put the value of the units and we'll find that which of the option gives the unit of length. What are the unit of length? Meter, centimeter, or kilometer. So upon putting the units, if we'll get any of the option, meter, centimeter, or kilometer as the unit, so that will be our option. So I have picked up the first option, 1 upon c square into g into g e square upon 4 pi epsilon naught whole power 1 by 2 whole raised to 1 by 2. So putting the value, what is the c? Velocity of light, that is meter per second square. So meter goes here, second square goes upside, so it is meter square per second square. G, from f is equal to g m1 m2 r square, that is the formula. I can get the dimension of g, I can get the unit of g, that is Newton meter square upon kg into kg square, Newton meter square upon kg square. For finding the value of e square upon 4 pi epsilon naught, I am having the formula f is equal to 1 upon 4 pi epsilon naught e square r square. So from here I can find the value of e square upon 4 pi epsilon naught, that is force into r radius square, that is Newton into meter square, and this whole power 1 by 2. So upon finding the value of this part, we'll get the second per meter square as same. Now it will be reduced to Newton meter square upon kg. So what is the value, what is the unit of now Newton? Newton is kg meter per second square. So putting that value, now we can see that second square get cancelled, kg get cancelled, meter square get cancelled, and we are only left with meter. So that is the dimension of the length, that is the unit of the length, that is the in dimension we can say that meter. M0, L1, T0, that is the dimensional analysis of length. So by saying the option and picking up the option, the first option that was given was directly the answer. Okay, they know that students are going to solve by this approach. So whenever a student uses his smartness to directly pick from the option he must get the benefit, so they have put this first option. Okay, now the next question is, the two rods A and B of different material are welded together as shown in the figure. This is the figure. The thermal conductivity is K1 for this is one K1, this is for K2. The thermal conductivity of the composite rod, whenever we are making the composite rod, combining the two rods, what will be their net thermal conductivity? Here are four options given, and now just look at the solution. Okay, so these are the two composite rod A and B having the uh, thermal conductivity S, K1 N, K2 the distance is D, and temperature at both the end is T1 and D2. In parallel combination, we always know that we are having the formula that R1 is equal to D upon K1A. What is A? A is the area. Okay, for R2 is similarly we'll get D upon K2A, and since it is a parallel combination, so 1 upon R is equal to 1 upon R1 plus 1 upon R2, putting the value. So by when the rods are combined, so their net equivalent area will be 2A, so we are going to put Tk upon K is the equivalent thermal conductivities. So we are going to put the value of area as 2A when they are combined. So d 1 upon d upon k 2A is equal to 1 upon d upon k1A plus 1 upon d upon k2A. So these will reciprocate and come upside, so k2A upon d is equal to k1A upon d is plus k2A upon d will get cancelled either side, so all and A will also get cancelled, so all we have left is K, that will be K is equal to K1 plus K2 by 2, so that is the fourth option. Okay, so this was the last question for the day. Thank you for watching the video. You can find me here on Unacademy. This is my id, unacademy.com/user/vikasjoshi official. Please do rate, review and share this video. Do share it with your friends, colleagues and everyone, because padega India tabhi to badega India. Let us educate each and every individual to make our nation great. Thank you.